بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Section 5.1 The Indefinite Integral. In this section we are given a function f and we ask to find a function capital F which is called antiderivative such that f prime x is equal f of x, and also to introduce the indefinite integral notation and relate it to antiderivative function. So here we have a definition 5.1 which is talk about the antiderivative. So a function f is said to be an antiderivative of a function f on some interval I if f prime x is equal f of x for all x in the interval I. So if we find the derivative of f prime x which is equal f of x, this will be in differentiation. Here in the integration or finding the antiderivative, we are given the function f of x, or we are given the derivative, and we ask to find what is the original function, and the original function we called it antiderivative. So for example, here we have example 1. Show that f of x is equal x squared is an antiderivative of fx is equal to of x. So the original function is x squared. We want to show that x squared is the antiderivative of 2x. So let us differentiate fx is equal x squared, and we want to show that the derivative of this one is equal to x. So we are given fx is equal x squared. So now we will differentiate f of x. This will give us 2x, which is equal f of x. So we conclude that this fx, which is x squared, will be the antiderivative of 2x, because if you differentiate x squared, you will get 2x. So we call that f of x is equal x squared is the antiderivative. Here we have a question: is there any other antiderivative for f of x is equal to x? So can we find another function? Once we differentiate, we get it is equal to of x. Let us see here some functions. So for example, we have g of x is equal x squared plus 1. If we differentiate g of x, it will be derivative of x squared plus 1, which is 2x, which is also equal f of x. So we called also x squared plus 1 is an antiderivative of fx. Again, if we have the function hx is equal x cubed minus 3, and if we want to find the derivative of hx, so dhx with respect to x will be the derivative of x squared minus 3, which is 2x, which is also equal f of x. So we conclude that x squared minus 3 is the antiderivative, also another antiderivative for the function f of x. Again, if we have another function f of x which is x squared plus c, where c is a constant, so the derivative of this function will be 2x, which is also equal f of x. So here we see that f of x, g of x, h of x, and this one f of x, all of them are the antiderivative of the function 2 of x. So to write the antiderivative of this one in general form, we see here this one is just x squared, this one x squared plus 1, x squared minus 3, x squared plus c. So the form of x squared plus the constant any number, this will give us this function will be the antiderivative of the function 2x. يعني نحن ممكن نحصل أكثر من antiderivative للفانكشن الواحدة، وذلك كيف الطريقة أن ممكن نغير الكونستنت. فنلاحظ إنه كل الفانكشن هذا g of x, h of x, f of x وال f of x اللي قبل كلهم يعتبروا antiderivative للفانكشن f of x. الاختلاف الوحيد اللي بينهم اللي هو نحن نغير فيه الكونستنت. هنا عندنا plus 1 minus 3 plus c، والوحدة كانت without constant or the constant is 0. فممكن نحصل أكثر من antiderivative للفانكشن الوحدة. So here we have theorem 5.1. If g prime x is equal f prime x for all x in some interval a to b, then g of x is equal f of x plus c for all x in the interval. So if two derivatives are equal, that means g of x will be equal f of x plus c. So for example, here we have, if we say this one g of x and this one and this one f of x. We see that the derivative of f of x is 2x, derivative of g of x also 2x. So we conclude that according to this, g of x will be f of x plus a constant c. And we see here that f of x, g of x is equal x squared plus 1, and f of x is equal x squared. So the relation between fx and g of x, that f of x is equal x squared plus 1, and g of x is equal x squared plus 1, or we can say f of x minus 1. يعني نحن هنا قلنا لو كان عندي اثنين derivative أو two function has the same derivative، إذا معناته إنه واحدة منهم تساوي الفانكشن الثانية plus the constant c. فنحن قلنا هنا ال fx عبارة عن x squared وال g of x عبارة عن x squared plus 1. الديريفيتيف مع g of x 2x والديريفيتيف مع ال fx عبارة عن 2x. فلما نجي نقارن بين الفانكشن fx وال gx نلاحظ إنه ال fx عبارة عن gx minus 1. حيث إنه gx x squared plus 1 لما نقص منها 1 تعطينا x squared which is give us the function x squared. So here we have another question. Do the following function f of x is equal sine square x, g of x minus cosine square x have the same derivative with respect to x. So we need to differentiate g of x, we need to differentiate f of x and compare their derivative. If yes, according to theorem 5.1, what are the constant c? So if they have the same derivative, we need to find what is the constant c. So we have fx is equal sine square x. So the derivative of fx will be here, since sine square x, it is sine x all squared. So the derivative will be 2 sine x multiplied by the derivative of sine x, which is cosine x. Here also we have g of x is equal minus cosine square x. So the derivative of g of x will be equal minus 2 cosine x, and the derivative of cosine x will be minus sine x. Here we have minus 2 cosine x multiplied by minus sine x, so it will give us 2 cosine x sine x. If you compare the derivative of fx with the derivative of g of x, they are equal. So we need to find what is the constant c, such that g of x is equal f of x plus c. So we know that the identity of the trigonometric function cosine square plus sine square is equal 1. So from here, sine square will be equal minus cosine square plus 1. So sine square is f of x, and minus cosine square it is g of x plus 1. So from here we see that sine square x, it is just f of x is equal minus cosine square plus 1. So from here we conclude that g of x is equal minus cosine square x. So f of x is equal g of x plus 1. So this is the relation between these two functions. We see that fx is equal sine square, g of x is equal minus cosine square. They have the same derivative, and we use the identity cosine square plus sine square is equal 1. From this identity we get that sine square is equal minus cosine square plus 1. So from here we conclude that if fx is equal sine square, which is equal minus cosine square plus 1, and g of x is equal minus cosine square, that means the constant will be 1, where f of x is equal minus cosine square plus 1 and g of x is equal minus cosine square. يعني نحن حاولنا نكتب صيغة ال f of x أو ال g of x بنفس الصيغة، يا أنهم كوزين سكوير أو ساين سكوير. نحن هنا اخترنا أنهم يكونوا بصيغة ماينس كوزين سكوير. فعندنا الساين سكوير عبارة عن ماينس كوزين سكوير بلس 1. الحين لما نجي نقارن ما بين ماينس كوزين سكوير بلس 1 وما بين كوزين سكوير، هما نفس الفانكشن بس نحن أضفنا هنا للf x 1. فمعناته العلاقة هذه إنه ال g of x is equal fx plus c, where the c is equal the constant 1. Here we have the indefinite integral notation. Integration of fx d of x is equal f of x plus c. This sign is the integral sign. This one is the integrand f of x. This capital F of x is the antiderivative. C is the constant of integration. So we have the integral sign, we have the integrand, we have the antiderivative, we have the constant of integration. So here we have note, differentiation and integration are fundamentally inverse operation. So if you see that the differentiation and integration, they are opposite, because the derivative of this one will give us this one, and the integration of fx will give us the capital F of x. So here we have integration of f prime x, this will give us f of x. And if you find the derivative of the integration of fx, so this will be equal derivative of integration of fx, which is fx plus c. So we find the derivative of fx plus c. What is the derivative of fx? We said here the derivative of fx is equal f prime x. So this will give us f prime x, and we say that f prime x, it is just f of x. يعني since هنا we have differentiation, we have integration, it will cancel each other because they are inverse, and just we will have f of x. يعني هما عمليتين عكسيات. لما أجيب الانتجريشن ولما أجيب الديفرنشيشن بخطوة متتابعة ورا بعض، إذا معناته إنه differentiation يكنسل integration ويبقى عندي الفانكشن بس اللي هي f of x. For example, if we have the derivative of sine x, this is cosine x. Now, if you want to find the integration of cosine x, you will back to the function sine x plus the constant c. يعني إذا الفانكشن sine x جبنا الديريفيتيف مالها cosine x. الحين إذا أردنا نجيب الانتجريشن مال cosine x بنرجع للفانكشن اللي هي sine x plus the constant c. So here we have table 5.1 for the differentiation formula and integration. For example, if you have derivative of x is equal 1, then the integration of this part with respect to x will be x plus c. Derivative of x power n plus 1 over n plus 1, this will give us x power n, where n is not equal to minus 1. But if you integrate this one, integration of x power n, it will be x n plus 1 over n plus 1 plus c. The derivative of ln absolute value of x will be 1 over x. If you want to integrate 1 over x d of x, it will be ln absolute value of x plus the constant c. For the integration, we add the constant c for all the function, but for the derivative, there is no constant c. If you know the derivative of the function, then it is easy to know what is the derivative or what is the integration of this function. For this table, we have also the integration and differentiation of all the trigonometric function. Here we have the integration and differentiation for the inverse of sine, tan, and sec only. And you see here the integration of e of x will be just e of x plus c, and integration of sinh will, integration of cosh will be sinh, integration of sinh also will be cosh. Here you have to see something. If you have here just integration of d of x without any variable, it will be just x plus c. If you have integration x power n, so it will be x power n plus 1, you divide by n plus 1 and then add the constant c. If here you have x power minus 1, so this will be 1 over x, and the integration will be ln absolute value of x. For this one, why we don't have the inverse of the others? So we have the derivative and we have the integration of this inverse function. Why we don't have the derivative of or the integration of cosine inverse, or for cot inverse and so on? That's because we know that the derivative of sine inverse 1 over root 1 minus x squared, and the derivative of cosine inverse will be minus 1 over root 1 minus x squared. Now if you want to integrate this one, it will be sine inverse x. Similarly, if you integrate this one, it will be the same function. If you want to rewrite it like minus cosine inverse x plus c. So if you have, for example, sine inverse x 1 over root 1 minus x squared, and derivative of cosine inverse minus 1 over root 1 minus x squared, the difference between these two just is the minus sign. So if you have the integration of this one with the positive, you can write it either the inverse of sine x or minus the inverse of cosine x, and for sure you will add the constant c. Similar observation hold for inverse cotangent and inverse cosecant. So if you know one, you can know the second one by multiplied by minus.